Good morning. Today is the 4th of March, 2020. Math 1, we're talking about dilations or scaling. Yes, dilation. That's the one we're doing right now from our dance. Nico, learning goal?
I can manipulate shapes using transformation.
Good. Gordon, the why?
Computer graphics are just transformations. I want to understand how software works.
Cool. Anytime you zoom in or out on a computer screen, it's actually a transformation or a dilation that's occurring, a scaling of it. It's making it, proportionally larger or proportionally smaller. It doesn't skew it, it doesn't make it look weird, it just makes it zoom in or out. And that's a dilation. So a dilation is a transformation that produces an image that is the same shape as the original, but is a different size. A dilation that creates a larger image is also called an enlargement. A dilation that creates a smaller image is called a reduction. Your eye, the pupil of your eye, dilates. It gets bigger. When it's bigger, it's dilated. When the pupil is bigger, it's a dilation. When it gets smaller, we don't call it a dilation when it gets smaller, but it's in math it is a dilation. Cool. So this idea, bigger, smaller, dilation. Well, here's how we do it. These are your notes. Boom, right there. That's it. I take a point, 3, 2, and I multiply both the x and the y of the point. So 3, 2 would become 9, 6. If I was dilating it by a factor of 3. So get this into your notes and then we'll do a couple practice problems. So we're going to dilate the square by a factor of 1/2. First thing I need to do is I need to figure out where each of the corner points are. All right, so Micah, where is this point right here? Good. This point right here, JJ?
4. Yeah.
Good. This point right here, Jackson?
-4, -4.
And this point right here, Lizette. They're the original points. I'm now going to dilate each of those points by a factor of 1/2, which means I'm going to take every number up there and cut it in half. So what would this be, Chris? Throw it away. Throw it away. What position do you play? Eighth position?
Outfield, third base, first base, catcher.
Second base?
Yeah, I can play second base.
Seems like everything. Okay, what was it, Chris? -2, 2, which is right here. This one, let's go with Taryn. 2, 2. Right there. Now, once you have a couple of the points, you can just build the shape. I know it's a square. It's still going to be a square, but we'll do the rest of the points. What's this one, Gavin?
2, -2.
And then that one, yes, Jordan.
-2, -2.
-2, -2. Boom, there it is. That's a dilation. Take each point and multiply it by whatever the scale factor is. This one, we're going to do it by a factor of 2. It's going to do something different than you think. Some of you think it's just going to go, oh, let's just double both sides, right? This is 2, that's going to become 4, and that's going to become 4. That's not the triangle. We actually have to look at it point by point. So where is point C, Presley?
1, 1.
1, 1. Where's point B, Greenlee?
Point B is at 3, 1.
3, 1. And where's point A, Bradley?
1, 4.
1, 3. Each of those points is going to get doubled. Double A for me. Maddie. 2, 6. Double B for me. Mr. Fisher.
6, 2.
6, 2. And double this one for me, Gavin.
2, 2.
So notice, it's going to do something different than you expected probably. 2, 2 is right here. Notice that point C actually moved to a new location. 3, what is it, 6, 2? There's the new shape after the dilation. But really, after you move one point, you can build the shape off of that. So as soon as I saw that, hey, C moved right here, I can say, oh, it's 4 by 4 and draw in the triangle. Questions about dilation so far? We will do another one.
It's fun.
They're fun?
They're easy fun.
Easy fun. I like easy fun. This guy, everything's going to get scaled by a factor of 2. I'm going to show you I can do this all with 1 point and then realizing that every side is going to get doubled. So let's start with 1 point right here. Where is that point? Where is that point? I need to talk to Nico. Nico, where is that point?
-2, -3.
Good. Nico, double that.
-4, -6.
-4, -6. Okay, -4, -6, right there. Now, off of that point, I know that point and that point are the same point. I can build the entire shape off of that. How long is this right now? 4. So how long should this be?
8.
8. 1, 2, 3, 4, 5, 6, 7, 8. How long is this?
3.
So how long should this be?
6.
1, 2, 3, 4, 5, 6. Good? Now from here to here, I went over 1, down 1. So what should I do?
Over 2.
From here, I went over 1. So what should I do?
Over 2.
And then from here, I went over 2. Well, actually, I just got to go to that other point, don't I? Now it's just connect the dots.
Yay.
Yay! You see, did I get it right? Oh, it doesn't even have an answer key to show me.
Yeah, you did get it right.
Thank you.
Probably.
So really, I can do it with 1 point and then build the shape off of this. This one, we're going to scale it by a factor of 2. I need 1 point. Pick a point, JJ. You want this point? You want this point? You want this point? You want this point? You want this point?
Yes.
You want to change your point?
No.
You want to pick another point?
No.
Okay, you're going to take this point?
Yes.
It's like a magic trick, isn't it? You sure you want that point?
Yes.
Okay. Where is that point, JJ?
0, 3, I think.
0, 2?
Oh, 2, yeah.
Good. Double it for me, JJ.
0, 4.
0, 4. There we go. That's that point right there. How far is this? 1, so this is 2. All right. So from here, I had to go down 1, 2, 3 over 2. So what do you want me to do? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. This is 1, 2, 3, 4, 5. So you want me to go? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Dilation. Boom.
Yay.
But if you don't like what I just did, you can do each point individually. Questions?
You should put the next one.
I should do the next one?
No.
Is there another one?
Yeah.
One
I like
last one.
this one.
Ah, let's do it. Okay, pick a point. Let's see, who am I going to talk to today? I feel like Miranda. Miranda, you want this point? You want this point? You want this one? You want this one? You want this one? Okay. Where's this point?
Three.
3, 3. We need to
Negative.
-3. Okay. Divide both of them by 3. Multiply them both by a third. That's the same thing. So what does this become? Gavin Wamsley.
1, -1.
1. So there it is, right there. This one's actually easier if we just do each of the points, probably. But well, I know, man. I can handle this. Ready? Count with me. 1, 2, 3, 4, 5, 6. 1, 2, 3. Up 2 over 1. Because I'm dividing everything by 3, right? 1, 2, 3, 4, 5, 6 divided by 3. 2.
Oh, I think we were dividing. Sorry.
And then over 1, 2, 3 divided by 3, 1.
Sorry.
Okay, let's do from here. 1, 2, 3, 1, 2, 3, up 1 over 1. From here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. 3, 1, 1, 2, 3, 1. There it is. Good enough, right, Nico? What position does Nico play, Nico? All the time?
Most of it.
I had to catch 2 games in a row.
You got a long life ahead of you.
I know.
I know. Although, I guess catcher is like one of the. Okay, I'm trying to say this correctly. It's one of the easiest positions to get into the majors with. I've been told. I mean, I'm not saying it's an easy position to play.
I think that and pitcher.
You think pitcher?
Pitcher.
I do. I definitely do.
Because you like to have like 10 players.
Yeah, you
Okay.
like, you like to have like.
So there's probably over 100 players.
Well, there got to be more than that. How many teams are there?
Well, there's probably like.
How many teams?
There's 30.
And just hit that with a 10. Hey, we're done. We're done.
I could imagine it'd be really hard.
Start your homework.